Okay, so on the back of worksheet 8, we're going to be looking at a probability distribution, which on your homework you are going to be asked to graph a little tiny one by hand. So I'm going to show you how you can get some stuff on your calculator to help you out, but really they're not that hard to graph by hand even without any calculator work. I know that chart for probability is already filled out on your paper. I want to show you a little shortcut that you can do on your calculator if you're ever in a jam for like a really long list of data. Because what you would have to do on your homework is if I gave you all this problem about, this is the binomial probability question, 20% of Americans have visited a doctor in the past 6 months, and we are talking to, I can't read, 5 people, so the n number of trials is 5, and they want me to fill out this probability chart and then eventually graph it in a histogram. So I know you guys already have the information, but that's because the book, or whoever did this question originally, already did this binomial, remember we use PDF for PreCalc, PDF for singular events. And they did 5, comma, 0.2, comma, and then they filled in each of these x values one at a time. Which is a little time consuming, right? You'd have to do like a bunch of problems. It's not, I mean, it's not terrible, but what if you don't want to? What if you have an even longer list and it's going to take you forever? So everyone grab your calculator. Even though it's already done, grab it anyways. And enter that x list into list 1. And clear out list 2. Get it ready to empty. Oop, where'd it go? Goes down to 5. So your computer, which it really is a computer, you can program it, especially in the list menu, you can program the list to do certain calculations. So like we did one, I think it was yesterday, where I had them take the entire list and find the probabilities by like dividing by a total. And that works for basic probability questions, but this is binomial, so it's a little different. So what you're going to do is you're going to go up to the name of list 2, and we're going to program that weird distribution thing into there. So while you're in list 2's name, pull up the binomial PDF distribution. And then do the same pasting of the information you always would have done, except when it says x value, I want you to put list 1 there, because that's where all your x's are located. I forgot what they were. Was it 5 and 0.2? Cool. Oops. Went a little too far there. Try again. 0.2. So in x value, put list 1. Okay. Now in the older calculators, you're going to do, it's going to look like that. 5, comma, 0.2, comma, list 1. So we're going to hit enter. And then voila! Now the only thing that looks a little different from what's already on your paper is this last one. They put it in scientific notation simply because of pixelation space that allows for the text. So it's 0.0003. So they just went ahead and wrote 0 on here. Do you have different stuff? I can go back. Yes. So back up to the top. I got to clear mine out, otherwise it'll get all messy. Okay. So if you had something cleared out and then go back up. All right, so you go to, while you're in the L2 menu, or the header, you go to distribution and make sure you pull up binomial PDF. We had 5 trials, 0.2 was the probability of success, and then L1 is all the x values that it's going to paste in. Oh, sorry. So 5.2 L1. Got it? And then when you hit enter, it should paste everything down. Got it now? Okay, great. So if you had, I mean, it wouldn't be that hard for you guys to calculate all, was it 6 of them by hand, but not by hand, but individually on the calculator. But if you had a longer list, that's pretty nice and easy, right? So then they're going to want you to graph the probability distribution by hand on one of your homework questions, guys. I don't really think graphing on the computer, on the calculator, and then going to do it by hand is like a necessary independent, like I don't think you need to do that. I think you guys can graph a bar graph just fine. So you would make a little mark at 0 on the x-axis, and then along, notice on your paper, it's already done for you clearly, but on your paper along the y-axis where the probabilities are being measured, it doesn't go really far up because you're measuring probability. So when I notice your probabilities which are right there. Voila. Whoops. Hold on. They don't go any higher than 0.41, so they measured their axes to go from 0 to 0.5, which makes total sense. And then every line was a tenth. So just because it's a binomial probability distribution, you can still say all that stuff about being skewed or symmetrical. Would you guys like to tell me whether this is skewed or symmetrical? It is skewed. How is it skewed? Where is it screwed up? Screwed up on the right. Yeah, I know, I agree with you, but this is how the math people want us to do it, right? I think, well, the screwed up thing is just something from my husband. That's the way his brain worked. It's not really how the math community determines it. I know, because my thought is if it's skewed, that should be where all the data is clustered, right? Is that what you're thinking? Oh, that's what I was always thinking. Well, yeah. The skewedness refers to where the tail is being lengthened unnecessarily, I guess it would be a way to look at it. So, well, I know, I agree with you. I don't agree how they're naming it, and does it really matter in the long run? No. Yes, it does. It's skewed right or positively, according to everyone in the math community except for us. Okay, so, sorry. I know, I disagree too. So the probability that at least 4 people said yes, meaning they would take 4, 5, and add them together. So that's really not that hard of a question, is it? Bada bing, we're done. So there's a question on your test that looks kind of like that, where you don't have to graph it, but it'll say find the probability of at least something happening. So you'll have to add a couple of probabilities together. We will definitely have a review questioning day before you take your test. I'll hand you a review a few days before it, like on Wednesday when you come back from testing. But I'm not going to probably be going over that review in its entirety at all. So you guys want to make sure that you are... What I am going to do, however, is answer questions on your homework. That's what I'm interested about. Not so much you doing the review. I mean, me doing the review. I want you to do the review. That's... Shut up. All right. Exercises. Sure, why not? Well, this looks fun. Let's do one of these. Let's do number 4. These aren't assigned to you, right? I'm not doing your homework by accident. I hate when I do your homework by accident. That's the worst. All right, no, they're not assigned to you, so let's do this one. A survey found that 60% of American victims of healthcare fraud were senior citizens. Oh, that's sad. Okay, so 6 victims of healthcare fraud will be chosen at random. So that number right there is our N. And this sounds really sad, but we're going to call probability of success 0.6, meaning that they were victims. That's kind of a weird phrase, but sorry. And then X being the random variable of senior citizens out of the 6 that we're looking at here. And they want to know the probability that at least 3 victims. So if I kind of interpret that a little differently, that would be 3 victims, or 4 victims, or 5 victims, or 6 victims. Now, for the way we've taught you to do this in PreCalc, that's a little obnoxious because you'd have to go find this and this and this and this and add it together, which is totally fine. But in hindsight, like, didn't we just do some cool stuff on the calculator? So maybe I want to do it that way. James, you can do the CDF. Do you remember how to do this one, though? So if you want 3 or higher, you would have to type, and you guys can try this if you've caught on to what James and I are talking about, but he's going to do a binomial Cdf where it measures, you have to go to the one right below it because it measures from integers, right? So he's going to do, what we got, 6 people, a probability of success of 0.6. He's going to measure from 2 down, but the CDF curve measures that way. So James is then going to have to take whatever this answer is and subtract it from 1. And that's going to be the right answer, okay? Now, for the rest of us, because on your test, I give you a question like this, but all you guys will have to do on your test is add up 2 probabilities. It would probably be easier for most of us who haven't had stats to just find those 2 probabilities and add them up, okay? I'm going to put a big line here, or... The rest of us are doing Binomial Cdf. We're going to do 6, comma, 0.6, comma, and then I'm going to leave this empty because we're going to keep plugging in numbers, 3 or 4 or 5 or 6, one at a time and add them up. Did anyone think of another way to do that, though? It's not really that much quicker, but could I find 0, 1, and 2? And then take the complement to it? Maybe. And you're like, well, that's not really better. It's 3 instead of 4, Bruzo, but whatever. Then I have to subtract, so it's really potato again. And remember what we just did in the calculator, guys? You could do that where we pasted the binomial formula into list 2. That was the other option, but you still have to add them up at some point. So choose one of these methods, and I want you guys to work until you get this answer. I got 0.821. Someone confirm that for me. Let's try. That was a quick yes. Did you even try it? You did the easy one, didn't you? You did the CDF? Okay, well, the problem with that, guys, is if you're going to use CDF, you got to know how we did that. You can. Did you catch on? Oh, well, fine then. Never mind. Okay, let's learn our last thing for a while, okay? This is the last thing I have to teach you until next week. Right? Yeah. That was a quick yeah from the seniors. They're like, yeah, because I'm not going to be here. Yeah, so today's Friday, right? So Monday, we're just talking SAT all the time. No offense to sophomores. It's not that I don't care about your PSAT, but a lot of what we say about SAT applies to the PSAT. So seniors are probably going to be at home doing their homework or in class doing their homework on Monday. Okay? If you choose to stay home on Monday, it's because you're doing your homework. Don't skip your other classes, though, because I don't... Knowing some of your teachers, they're probably giving a test on Monday. All right, so this topic is actually kind of cool. It's called expected value, and it's the idea... Unfortunately, there's a lot of examples for expected value that have to do with gambling. So it's not really applicable to you guys. But, for instance, like lottery tickets. You know, how can the state afford to hand out a Powerball prize of, $430 million? Like, how does that work? Well, because they've calculated, this is part of actuarial science, they're going to come out ahead. Like, they're not going to be in the hole at any point because of the amount of people that are going to be buying tickets that have very little chance of winning, right? So the odds are not in the buyer's favor. In fact, we can calculate exactly how much your lottery ticket is worth when you look at the grand scheme of things. And usually the answer is your lottery ticket is worth negative dollars and cents because you're just going to be paying for the lottery ticket and never winning anything. And that goes for pretty much all types of gambling. You know the saying, the house always wins? That's what it is. In the game of large numbers, yes, this dude next to me is playing the slot machine and wins $4,000. Good for him. But everybody else around him has lost way more than that. So the house has always fixed the games in a way, and even like games that are not in machine control, like poker and blackjack, everything is fixed in a way where the odds are not in the player's favor. Overall, the players are going to lose big and the house is going to win big. Okay? So the idea is you have to come up with all the possible outcomes for expected value. So the outcomes are, I'm going to win or I'm going to lose. And then sometimes like on a raffle ticket thing, there's multiple ways to win. And then you're going to attach the probabilities of all those events to each of those numbers. Okay, that's what we're going to do today. So like for instance here, we have a raffle ticket. They're selling raffle tickets and they're going to sell 500 tickets. This is straight out of your textbook. I don't think it's on your paper anywhere, and that's okay. They're all sold for $1, and then they're going to give out 3 prizes. So you're either going to lose your $1 because you don't win anything, or you're going to win $100, $50, or $10. Now, did you actually win $100? No, you actually won $99. Why? Because you bought the ticket. And then are you actually going to win $50? No, you're really going to win $49. And same thing here, you're going to win $9. So, what they have here, they put it into a table. We're just going to set it up as like an algebraic, not an algebraic expression, but a numeric expression when we do ours. So the $99 winnings, you only have a 1 in 500 chance of getting that. Because 1 out of the 500 tickets will win $99, will win $100. And then the $49 winnings, again, you only have a 1 in 500 chance of that. The $9 winnings, you have a 1 in 500 chance of that. So if we added this times this, plus this times this, plus this times this, plus this is the most likely outcome. The most likely outcome, you have a 497 out of 500 chance of just flat out losing your dollar. So then when we add all of these together, which they've set it up in a way where your calculator would do it for you, so they multiply list 1 times list 2 and then boom, it pops out. Most of us are not going to take the time to enter it into list 1 and list 2 because it's kind of a pain. But you find out that this raffle ticket is the expected value means the average loss for someone purchasing this ticket is 68 cents. So the ticket itself, you could think of it as worth a loss. Yeah, those 3 people are going to win some money, but the probability of you being one of those 3 people is so low that you're pretty much banking on the fact that it's going to lose. Now, what does that mean for the people who are selling the raffle tickets? That means that they're going to be guaranteed pretty much by the probabilities of everything to be making money. So sometimes these questions are set up really dumb. Like for instance here, they're giving out $100, $50, and $10. So they're giving out $160 and they're selling $500, right? So they're going to make a profit regardless of the outcome of who wins because they know like they're going to pay the same amount. Sometimes we make up problems and we look at them at the end and we're like, well, that was dumb. Like the raffle prizes are more than the raffle tickets. So if that happens, I'm sorry. And that's just an oversight on my part because usually that means I made up the problem. So sometimes kids don't notice that and they're like, that was weird. Okay, so let's take a look at some examples that are on your paper. Let's look at that race question. So the resort is going to plan a bicycle race. And the cost of sponsoring the race is $8,000. The resort expects to make $15,000 on the event. But you're in some place where a hurricane is possible. So there's a 30% chance that a hurricane will arrive the day of the race. And if this happens, the race is just canceled and they still have to pay this cost right here. So they have to pay this regardless. So there's 2 outcomes, right? It's either they're gonna be a hurricane and they cancel the race, or the race goes on. So let's talk about the optimistic one. Let's pretend there's no hurricane. What is the probability that there is no hurricane? 70%. And how much money will the resort make? How much profit will they make? 70% likelihood. Yes, it's actually $7,000. Where'd that number come from? Yes, they're going to make $15,000, but they had to pay $8,000 to put the race on, like buy all the stuff and hire the people, get contracts going. Now, what's a much more likely, or sorry, hopefully less likely event? It's 30% that there's a hurricane, and what's going to happen if there's a hurricane? Well, they're not going to get any of the $15,000, but they did what? They had to pay the $8,000, so they're going to lose $8,000. So this is you trying to convince your boss to go ahead and schedule the bicycle race because you're doing the math and you're going to say, well, look, according to the probabilities, what does this come out to? I know it's positive. It's 2,500. Okay, cool. Now, that's going to be a hard sell if you're just doing this bicycle race like 1 year, but if this is an annual thing, you tell your boss like, yeah, I know we had a hurricane last year and we lost a bunch of money, but, you know, according to the statistics, the odds of it, we aren't probably going to have a hurricane again this year, guys. Like over the long run, over the course of a couple decades, we're going to keep making money off of this race. We should keep it going. Okay, this is a very light dip your toes in moment of actuarial science. Have you seen the movie, is it Along Came Polly, where he's like a risk management assessor or something? No, just me, old lady movie? Okay, cool. So they, basically he's I don't know what his title is in there, but he's looking at a very adventurous billionaire and they're trying to get life insurance on him, but he like does things like skydive and stuff. So when you get insurance, they have actuarial people who do the math and they determine like how risky you are. Boys, that's why your car insurance is significantly higher than girls, because boys are more likely to be in a car accident than girls, apparently. I don't know if that's still true with cell phones and everything, but sorry, girls. I see you putting your makeup on in the mirror too. No, so I wouldn't. So As you get to like a certain age bracket, your insurance goes down, or like if you buy a certain kind of car, your insurance goes up, and that's because of the statistics behind how many accidents and claims have been given on people in your group. So blame the other teenage boys, not you. All right, insurance. Oh, look at that. So an insurance company insures a painting worth $20,000 against theft for $300 per year. So how do they come up with this $300 amount? And that's because of our mathematicians who have calculated, like, this is a good amount for you to charge because you're going to make money off of this insurance company. The company assessed the probability that the painting being stolen in a given year is 0.002. What is the insurance company's expected annual profit? Spoiler alert, it's always positive for insurance companies. They're always going to make money off of you. So there's two outcomes. Either the painting is going to be stolen or not, right? So in the event that the painting is, what do you want to start with? Stolen? Not stolen? Stolen? Okay. Jeez. All right. So the probability that it is stolen is 0.002. Now, how much is the insurance company going to make off of you? Well, okay, that's kind of a weird way to say it, I suppose. The insurance company takes in how much money from you, from the customer? $300, right? So they took your $300, but when the painting is stolen, what else happens? The insurance company has to write a check to you for $20,000. So they're going to actually, this is the insurance company's point of view, they're going to lose that $20,000. So essentially they only lost $19,700, right? But remember, they have like 4 billion customers, so they're okay. Don't worry about them. Now, what's the much more likely event? Is that the painting is not stolen, right? Oh boy. What is that? 1 minus 0.002 is 0.998? Okay, cool. And then in that case, what's going to happen? Painting was never stolen, but you just took the customer's money, so you, as an insurance company, are going to gain $300. Thank you for your money. Calculate that for me, y'all. Is it positive 260? Okay. So if you're an insurance agent and you literally have one customer and that one customer has a claim, you're in trouble, but that's why they don't allow that, right? The insurance company has many, 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 many customers who pay many, 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 many premiums, and trust me, they make their money on you. This is a much more lighthearted conversation than the gambling one. What, you children don't gamble? All right, let's look at a raffle. There's a lot of raffle questions on your test, I've noticed. I think we tried to stick with, like, the idea of gambling, but, like, legal gambling that you're allowed to do. Y'all can buy raffle tickets, right? Or no, can you not buy raffle tickets? I don't know.
Someone tell me before that.
I think there's actually a rule for Nic 10 athletes that you can't buy raffle tickets, and you actually can't, like, be involved with them at all. There's, like, some weird rule, because it's gambling, essentially. Yeah. I don't know. I remember that at one point, yeah. Suppose we... Oh, cool. Suppose we hold a fundraiser and sell raffle tickets to win a TI 35 worth $15, or a TI 83 worth $45, or a TI 83 CE color edition worth $100. One of each will be awarded. If we sell 50 tickets for $1 each... Okay, can we just stop right there? Apparently I wrote this question. You see a problem with this question? Now, maybe these calculators were donated to me. Maybe that's what happened. Maybe I didn't pay for them in the first place. I'm not going to make any money if I had to buy these calculators. So hopefully they were donated. Let's find the expected value of the ticket. All right, so what's the most likely outcome of this situation, guys? We're just gonna buy the ticket and not win. So 50 tickets, and we have 1, 2, 3 winners, which means we have how many losers? 47 out of 50 chance of being a loser. And when you're a loser, what happens? You lost $1, so you're -1. Now, slimish chance of winning the first calculator, but be careful, it's not really a $15 prize you're winning. It's really a $14 prize. Now you can put 15 minus 1 right here. I just make it a 14. All right, same thing with the other two calculators. They're really only worth $1 less than that. And they're all a 1 in 50th chance. Oops, rest of the fraction. And then you're just going to carefully type. Guys, there are other ways to do expected value, and probably in your stats class you had a little bit of a different formula. There's other ways to type this in. Like you could factor out the 1 over 50 if you wanted to. But I just find for kids in pre-calc, I'm going to ask you one question on this. So just type it in an easy way for yourself and get the right answer. How much is this ticket worth? This is what I do now. Oh, sure she does. It's no. Right. Well, okay. So, yeah, I'm with you. That's a very good question. Okay, so they're all independent events from each other, and they're not dependent. So it's not like at that very moment in time I'm drawing your ticket out. It's just at the beginning of the raffle. The expected value is the overall value of the ticket, like before anything is drawn. So it doesn't have to do with like when something is drawn. That's a very good question. That is very good. If I wanted to calculate the probability, like if the first 2 tickets were drawn and I was like, okay, I need to know the probability of me winning because I really, really need that calculator. Like we could recalculate your probability, but the expected value of your ticket does not change. Okay, very good. Is this positive 220? Cool. So this would be a, decent raffle to go into. Seems like, I mean, you might win 1 out of 50 tickets. So there you go. Okay, so you have an assignment. It's on your homework check, so you have to write it down. But it's the side A of 8.5. Side B of 8.5 was assigned to you last night. And then worksheet 15A, which I think it's just 3 questions though, isn't it? Isn't it just 3, 4, 5 or something? Yeah, it's just 3, 4, 5 on worksheet 15A. The 3 expected value questions. So I'll post those keys up for you today. Can we finish that yellow one? I really need to be done with that packet. We got this. 2 problems. And then on the pink one, we'll keep going through questions until the bell rings, but I will post an answer key to the pink one. And then if you have questions on Monday, juniors, you let me know about that pink one, because we don't need to talk about testing for the entirety of the hour on Monday, but I want to give you a good 15-20 minutes to ask questions about what you're going to do. All right, last 2 questions, huh? Cool. Oops. So that one is our first one we have to look at? Oh, it's about fish. Well, didn't we have a bunch of fish questions? I don't know. Was this the class? I was like, oh, look, another fish question. All right, so a random sample of 21 brown bull-headed fish. What? Is that a fish? Oh, I'm sorry, Mr. Fisherman. It's a catfish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24 is removed? Whoops. So, you have an option of entering all this data into your list 1 and doing one variable stat and writing down like the mean and median. The range is easy for you to calculate without your calculator. And then remove the 24 and then do it again. And that's probably the safest way to do the question, but I think we can make some eliminations here. Which one of those measures of central tendency is changed the least by outliers? The median should not be affected by outliers very much. I mean, it's going to be affected, but not by much. So I don't think median's the way to go, but before I say that, uncertainty limit, yeah, okay. So they will change the same amount is probably not correct, because what we're going to do right now is we're going to find the range in example 1, 2, and then we will have to, you know what, I think we might as well just do this in the calculator. Can we just pretend we put it in the calculator? Okay, so you would have put these in the calculator somehow, whether it was by hand typing and found the average, and then recalculated the average with the 24 taken out, and you would have found the difference between, population 1 and 2 and written that down. Let's talk about range. Range is defined as what? Highest minus lowest. So who's the smallest little fish in the pond here? 8. So the range when the 24 is in the data is, I can do that, right? 16. And then the range the second time when we take out that 24 would be 8. So the range changed by going down 8 units. So when I calculated the mean, which I think without actually calculating it, guys, are you okay with me saying like the mean is not going to be affected by more than 8 points? Like that would be crazy. So the range is the biggest change. Now I'm a rule follower by nature. So I'm always trying to impress my math teachers of the years past. So I'm always trying to think like, what does my math teacher want me to do? So I probably would have entered it into list 1 and done the calculations all the way through because I got nervous. If I was short on time, that would have been a bad move. This is on the calculator test, right? Yeah, cool. All right. Last one. All right. Dreams recalled during a week. So data above for a sleep researcher studying number of dreams people recall and asked to record their dreams. Group X consisted of 100 people who observed early bedtimes, and Group Y is 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one, oh, right there. They didn't say the word given, but this is a given question. This is a conditional probability. If a person is chosen at random from those who recalled at least one dream. So you can't look at the none. Oh, this is kind of confusing. Okay, you got to look only here. What's the probability that they were from group Y? Well, I need you to figure out how many are in group Y. Let's start there. 79. And then don't get excited because there's a few with 79 in the numerator. And then it's only out of the total from here. So what's the total right here? 164. Okay. Is that an answer? Oh, yeah. So notice they didn't say the word given, but they implied a condition to your probability, which is the same thing as you highlighting your data. So you got to watch out for those. They often will ask you a conditional probability question, so be careful. All right, can y'all look at the pink worksheet? I'm just going to hurry up and tell you, are you okay if you just write down the answers, juniors, or does that bother you to try a question staring at the answer? Do you want me not to tell you the answers? I mean, I'll post the answers. Okay, then I won't tell you. I can kind of set you... I pulled these questions out of a test because I thought they were ones that maybe pre-calc students at this stage in the game might need to review. So I will tell you which ones are extra exciting. Some of them aren't really that bad. And actually, I personalized this worksheet for you guys. So where'd my worksheet go? There it is. So I won't tell you the answers. I also won't have any computer working. Okay, here we go. But I will tell you which ones are, especially for someone who like maybe has already been to SAT prep over the week or have been watching the videos. There's some kind of repeated topics on here, so I think you'll do those fine. Watch out. Well, let's be honest. Any geometry question is always a good time for you guys because it's been a while. So anytime it looks like geometry, you might want to take a look at it. But something like this guy, I worry about you guys doing that one effectively just because of sloppiness. So maybe check that one out. Geometry question, always a good idea. This question here is a lot trickier than it looks, but once you figure out the trick, it's pretty nice. This one's pretty basic if you've been to SAT prep or watched any videos, so I won't worry about that one. This question really messes with kids. I would maybe pay careful attention to number 20. And also, guys, please pay careful attention if it's in the calculator or no calculator section. So if it says it's no calculator, don't bother touching your calculator while you're practicing. That one's actually not bad. This one. There's a lot of inequalities on the SAT, so you need to maybe review what it means. Oh, it's geometry, so you know I would tell you to look at it. Please look at it. And this question, the only thing that really, well, there's two things that are going to be a problem in this question. Do you remember what makes a fraction undefined? What can you not have in the denominator? So this thing right here cannot equal 0, but there's a major problem going on here, guys. It's not in anywhere close to like a solvable form. So you have to like really manipulate this, like FOIL it out. And this is the part I'm extremely worried about. Why? A whole bunch of kids go, oh, well, that's x squared plus 25. And then I want to, like, you know, forehead smack myself. No, it's a foiling question. It's x plus 5, or sorry, x minus 5 times another x minus 5. So you have to do a little bit of work there. So watch out. And then once you get it in standard form, you can tell me the values that make it 0. But pay careful attention to that question. And that's the end. So sorry, it's not as exciting as I was hoping. So seniors, I understand if you're not excited to look back at SAT questions. Juniors, please look at them and then tell me which questions you can't figure out on Monday. On Monday, we'll do that. Plus, we will talk about all the logistics of Tuesday. Okay? Have a good weekend.